This is the S1 paper, June 2005. The time is 1 hour 30 minutes and the total mark is 75 marks. Now there are 7 questions. Usually there are 6 to 7 questions and you have to answer all the questions. And in the exam they're going to give you a formula booklet with statistical tables. That means the normal distribution table would be there, and there would be also some formula that you can look up from that table that will be provided in the exam. So let us start with the first question. The first question deals with correlation. Now here they have given us 3 scatter diagrams, and what we have to do is we have to compare the correlation, product moment correlation coefficient means correlation, with these values of the correlation, and we have to give a reason for that. It's a total of 6 marks. A little review is, when we talk about correlation, it tells us whether there is any connection between two data set. Suppose you have one data set X and you have another data set Y, and what you want to know is there any connection between this? And this value, correlation, that we calculate, this value can give us a idea whether there is any relationship or not, and that is given by 2 things. First of all, if correlation is a positive value, then it means if one of the value increases, the other value will also increase. That's called a positive correlation, and it is same relation. If R, the correlation, is negative, that means there is an opposite correlation. If one of the value is increasing, the other value will decrease. That's the positive and negative correlation. That's what we refer to. Now this can be expressed in the form of a scatter diagram. Scatter diagram is nothing but the 2 values plotted. So suppose this is X and this is Y, and if you plot them and they're just going down, then we call it a positive correlation. If the scatter diagram is going up, as X increases, Y is going up. As X is increasing, Y is going down. So no, the first one I made a mistake. The first one is negative correlation. This one should be a negative correlation. Sorry about that. So this is going down, so it's a negative correlation, and this is going up. This is a positive correlation. And this one, where it is just seem to be randomly moving about, going nowhere in a circle, this means there is no correlation. Usually when we have a value of 0.0 something, that means no correlation. So this is a scatter diagram, and the scatter diagram gives you an idea about the correlation. It also actually gives you an idea about regression, but let's not talk about that. So here, this one, let's start with diagram A. So diagram A should have correlation. Notice that this is going down, so negative correlation, minus 0.79. So what is the reason? As X increases, we are always going to refer to this as increasing. Y is decreasing, Y decreases. That's the first one. So this is 2 marks. First mark for writing this, selecting it, and the second mark is for giving the reason. Now diagram B. Diagram B, it's sort of, if you look at it, it's not going anywhere at all. So it's like this one. So it has no correlation, so that means 0.0 something. So R equals to 0.0 something. So as X increases, now this is a mistake that most people make, and I also made that mistake. This is not X and Y, this is U. So the X is U here and the Y is V there. So be careful, this is the trick, otherwise you will not get any point at all. So at U increases, U is the X here, V is changing randomly. That means it is neither increasing or decreasing. At one point it is below, at another point it is above. That's what it means. The next one, diagram C, is this one. It is going up, so that means R equals to 0.68. so be careful, this is S and this is T. So as S increases, T increases. So that's why it is going to be a positive correlation. So this is a negative correlation, and this has no effect at all. The next question, this is a grouped data and the frequency for all the group data is given. It says the following table summarizes the distance. So these are the distance: 41 to 45 kilometer, 46 to 50 kilometer, and on, that 134 examiners, if you add up all the examiners, it will be 134, traveled to attend a meeting in London. So that means 4 of them traveled around 41 to 45 kilometer, 19 of them traveled around 46 to 50 kilometer, and so on. So this is grouped data, because after all, distance is continuous data. Continuous data is data that cannot be counted and it needs to be measured. So whenever we have continuous data, we group it and mention it like that. The disadvantage here is that we don't know exactly how much distance did each of them travel. We just know it's somewhere around 41 kilometer to 45 kilometer, but it's very helpful to group it like that. So the first question is, give a reason to justify the use of a histogram to represent this data. Remember, a histogram is the representation of continuous data, so distance is continuous, so that's the reason. So this should be, since distance is continuous, we need to use a histogram. That's it. The next question, calculate the frequency densities needed to draw a histogram for these data. Do not draw the histogram. They're very worried that you'll draw the histogram. Please do not draw the histogram. They usually mention this. If you don't have to draw the histogram, people draw it anyway, so they are very worried, and they always mention this in bold capital letters. So a little review. So histogram, they have a special relationship where you know that the frequency and the area, they are proportional. That means the area is some number multiplied by the frequency. Now suppose this number is 1, we assume it's 1, then the area would exactly be the frequency. Now if this is a building, if this is a histogram, part of the histogram, this in geometric terms is the height of the histogram, meaning the height of the rectangle, and this is the width of how wide the histogram is. So area of a rectangle is length into breadth, so this area can be written as height multiplied by the width equals to frequency. So we can say the height of the histogram is equal to frequency, meaning the area, divided by the width. So we write this as a special formula. The height, we call the height by a special name, frequency density. Frequency density, so we call it FD, and the frequency is frequency, and we call this width the class width. The class width, how wide the class is. The class width is calculated by taking the upper boundary of the class, upper boundary, minus the lower boundary of the class, lower boundary. Remember, whenever we have a gap, So since the data is continuous, we need to fill this gap up. It's like bricks. So when you have bricks and the data is continuous, you cannot allow this gap to take place, so fill it up with 0.5. so the last value of the class, we just add 0.5, so the upper boundary would be 45.5 and the lower boundary we just remove 0.5, so 40.5. These are the class boundaries. That's how we calculate the class boundaries. So this rule is a very fundamental rule for histogram, finding the frequency density. Remember, it's not the same thing as the frequency. So they asked us to calculate the frequency densities. So frequency density is frequency divided by class width. So frequency is 4 divided by class width. Now every time if you want to do 44.5, let me bring out my calculator. Every time if I do 45.5 minus the lower boundary, 41 less than 0.5 is 40.5, so 40.5, so you'll get 5. So if I write 5 here, it's fine, but it's a problem doing it over and over again. So there's a trick. Whenever you have a gap, then all you can do, instead of doing 45.5 minus 40.5, you just do 45 minus 41 plus 1. This 0.5, that 0.5 together is plus 1. So that's much faster. So let's use that for the next one. So this one would be 45 minus 41, which is 4 plus 1, 5. Same as 45.5 minus 40.5. The next one, the frequency is 19. So the class width would be upper minus lower plus 1. I'm using the shortcut when we have gaps in data. If there is no gap in the data, if this was 50 and this was 50, we just subtract it, that's it, because the class at the end, these are the boundaries, no need to add up. So 50 minus 46 is 4 plus 1 is 5. Then 53 is the frequency divided by class width. 60 minus 51 is 9 plus 1 is 10. This is much easier. 37 is the frequency divided by 70 minus 61 is 9 plus 1 is 10. Then 15 divided by 90 minus 71. 90 minus 71, let me check. 90 minus 71 is 19 plus 1, that's 20, so this would be 20. Last one, 6 divided by, this is a bigger one, so let me use the calculator. 150 minus 91 plus 1, that would be 60. Okay, now let me calculate. 4 divided by 5 is 0.8. 19 divided by 5, need the calculator again. So 19 divided by 5 is 3.8. If you divide anything by 10, is just point that, so 5.3, 3.7. 15 divided by 20, so this one would be 15 divided by 20, that's 0.75. 0.75. 6 divided by 60, that should be 6 divided by 60, 0.1. So that's the frequency density, and do not draw the histogram, be careful. Okay, the next question is our favorite linear interpolation formula for the estimate of mean and quartiles. So if you remember, the steps are, since the data, it's grouped data, we cannot actually find the exact values, it's an estimate. Now step 1 is find the position, then find the class, and then use the interpolation formula. The position for the median is n by 2th position. For Q1 is n by 4th position, and for Q3 is 3n by 4th position. So these are the position. Now the interpolation formula is this. lower boundary, lower class boundary plus position divided by frequency of that class, let me call it class frequency, subtract cumulative. The word cumulative means total, so cumulative frequency. Now cumulative frequency means total frequency up to that class, meaning up to the previous class. So remember, cumulative frequency of the up to the previous class, and with this, just move it here, you multiply the class width. That's it. This is the linear interpolation formula. So let's start with the median. So we find the median position. So there are 134 data divided by 2th position. Now remember, in median, if we have even number of data, there is no middle, so we have to take 2 positions. So 134 divided by 2 is 26 to 12 and 2 7s are 14, so 67th. And be careful when you write this, it should not look like 8. This is and 68th position. Then median class. So let's count where this is, the 67th and 68th position. So 4th position plus 19 is 23. 23 plus this is going to be 70 something, so roughly 51 to 60. This is going to be the median class. 61 to 70. So 61 to 70. Here 2 positions doesn't really matter because it's the same class. So therefore median equals to lower boundary of this is 60.5 plus position is going to be 134 divided by 2. Remember, you have to write the position as it is. Class frequency is, so 61 to 70, the class is 37, so the class frequency is, sorry, 50, should be 51 to 60, because 4 plus 19 and 53, this is 51 to 60. It should be this one. Let me remove this. Okay, it should be 51 to 60. Okay, good enough. So 51 to 60, so this would be 50.5. okay, so this position is the frequency of the class. 51 to 60 is 53, so class frequency is 53. And we have cumulative frequency up to the previous class. Now the first is 4, and if we add 19 it is 23, so this is up to the previous class. The total frequency up to the previous class is what we need. This is the class where we are in. The previous class is 4 plus 19, if we add up the frequency it is 23, so this would be minus 23. Now the class width, so the class width is going to be upper minus lower, so 60 minus 51 is 9 plus 1, the shortcut 10. Now let me show you in great detail. Many people say that they are getting different results, so it is extremely important to do this calculation very carefully. So I want you to really pay attention on the calculator, because you're not supposed to get different results, you're supposed to get the same result. Remember, this is math, it cannot be different, it has to be the same answer throughout. So let's start. Let me show you the calculation. Pay attention. Now whenever you do this, try to do it from the innermost bracket. Remember the steps. PEMDAS, bracket first, and that's how it works. So let's calculate 134 divided by 2, that is 67, minus 23 minus 23. We get this value 44. Now we have done this. Let's divide by 53. So divide by 53. So now we get this. So this thing is multiplied by 10. Remember, multiplication first. PEMDAS, PEM, M for multiplication. So multiply by 10. So after everything has been done, we can add with 50.5 plus 50.5. That would be 58.80189. 58.80189. 5 decimal places is a good idea. So 58.80189. Always like double check whether I have done it correctly or not. Okay, this is done. The next one is Q1. So let me do it here because of space. So let me write an AND so that there is a structure to the sum. So whenever someone is checking it, they know this is different, this is different. So Q1 position. Q1 position is n, which is 134 by 4th position. So 4 3s are 12. So 1 4. Oh, I have to calculate again. 134 divided by 4. 33.5. That means 34th position. So Q1 class. So 34th position means 19. 9 plus 4 plus 19 is 23. 23 plus 53 is something 70 something. So 35th position is also here. 51 to 60 is the same class. So 51 to 60. So therefore Q1, let's calculate it. Lower class boundary is 50.5 plus position 134 divided by 4 divided by frequency of that class, same as before, 53. Frequency of this class, same as before, 53. Total frequency up to that class, so 9 plus 19 plus 4 is 23. So this will be 23. And class width, so upper minus lower, 60 minus 51 is 9 plus 1 is 10. So let's calculate again. So pay attention again. So let's start from the innermost. So 134 divided by 4 is equals to 33.5 minus 23. So 23 equals to 10.5 divided by 53. 53. We get this. Okay, multiplied by 10. Remember, PEMDAS, the order of operation, is this. Now we have to add it with 50.5. 50.5. That is 52.48113. 52.48113. Let me double check. 52.48113. Okay, that seems all right. So this is Q1. Now let's move on to, let's do it here, Q3. Of course, you do it in your exam paper just below, just vertically, one after the other. Since there is a space problem here, I'm doing it side by side. So Q3 position, it's 3n, n is 134, divided by 4th position. So let's calculate this. This is going to be 3 into 134 divided by 4. This is 100.5. That means you take the nearest whole number, 101st position. So Q3 class is going to be, if we go back, so we need 101st position. 4 plus 19, if we add up the positions, let's use this. So position 4 plus 19 plus 53 is 76 positions. Up to this 76 position, let's add 37 plus 37. So when we come here, it is 113 position and we need 101 positions, so it should be 61 to 70. So 61 to 70, so 61 to 70. Therefore Q3 is going to be lower boundary, which is 60.5, plus position 3, n is 134 by 4. Frequency of this class, let me check. So the frequency of this class is 37, and the cumulative frequency, meaning cumulative means total, if we add up all the frequency up to this class, it is going to be 4 plus 19 plus 53, 4 plus 19 plus 53. So 4 plus 19 plus 53 is going to be 76, and the frequency of this class is 37. Okay. So this is going to be 37 and this is going to be 76. Okay, class width, upper boundary minus lower boundary, 70 minus 61 is 9 plus 110. Okay, let's write down Q3. Okay, let's start from the internal of the bracket. 3 into 134 is this, divided by 4, 100.5. So we got this one, minus 76, minus 76. We got that, divided by 37, 37. We got this, into 10. Okay, plus 60.5, 60.5 equals to 67.12162, 67.12162. Let me check again. 67.12162. Great. Then it makes sense. You should have an idea of whether it is right or wrong by looking at this. So the Q3 should be between 61 to 70, and it is between 61 to 70. So at the end you restate your answer. So answer median equals to, our median was 58.80189. So 58.80189. Our first quartile was where was it? 52.48113, and our upper quartile was 67.12162. So these are the three values. The next question is, I think it's still here. Yes, it is question number D. Now we have to calculate an estimate mean and estimate standard deviation, and they have already given us the estimates. So let me do it here. Okay, so this is D, estimate mean. Remember, when the data is grouped, we don't know any actual data, so we have to find the estimate, and the formula for that is, estimate mean formula is, we have to do this summation of mid into frequency divided by total frequency, meaning total number of data. Now the mid is calculated by adding each of the class and then dividing by 2. That's how we calculate the mid. And for estimate variance, Same as before the formula, but the only difference is that it has to be mid. So summation of, instead of x square, is class mid square into frequency divided by total number of data, total frequency, minus estimate mean whole square. Again, remember, this class mid is calculated by a plus b by 2. So that's how this is done. And the variance is sigma squared, and standard deviation would be square root of that, meaning only sigma. So when we do this calculation, we have to calculate this divided by total number of data. But if you look at this, they have already given the value, summation of f into this, they have already given the midpoint, and they have given us this value. So 8379.5, 8379.5, that is the value divided by total frequency, which is 134. So let us calculate the estimate mean. So 8379.5 divided by 134, that would be 62.53358. 62.53358. 62.53358. That is the estimate mean. The next one is estimate variance. Remember to write the word estimate. So we need this summation of mid square into frequency, and they have given us this value. It is 557489.75. So 557489.75 divided by total number of data is 134 minus mu squared, that is 62.53358 whole squared. So let's calculate this. So it would be 557489.75 divided by 134. This is what we get, minus, now we need 62.53358 whole squared. So the variance is going to be 249.9226. 249.9226. Let me check again. 249.9226. That's all right. Now square root of this is going to be the standard deviation. So let me write here estimate standard deviation. So it would be 15.80894. 15.80894. That would be the standard deviation. Okay, let's move on. They didn't mention anything about significant figures, so 5 decimal places is a very good idea. The next one is, they said they have given their own formula for skewness. So they're telling us to put the values of Q3, Q2, Q1 here and find the value of skewness. This is a formula they have given. So Q3 is, let's put the values so that we can look at it. Okay, we have this here. So we have Q3 is 67.12162 minus 2 into Q2. So minus 2 into Q2 is 58.80189 plus Q1 is 52.48113 divided by Q3 minus Q1. So Q3 is 67.17162 minus Q1 would be 52.48113. so that's what we have to calculate. That's a pretty big calculation. So take a deep breath and let's try to do this. Now let's calculate the upstairs first. 67.12162 minus 2 into 58.80189 plus 52.48113 equals to this. So it's negative. Now divide it. Be careful, calculator doesn't understand division very well. It can handle plus minus multiplication without any brackets, but division is a problem, so give a bracket. The whole thing is divided. So 67.12162 minus 52.48113 bracket closed equals to, this is going to be minus 3.96 minus 3.96 minus 3.96 1686. So this is the skewness, and so this is going to be, what type of skewness this is? You have to mention this is a negative skewness. This is a negative skewness. That's it. So the final one, question number F. Give another justification for your comment in part A. You know, there are quite a number of ways of talking about skewness. One of them is the mean and median. That is the easiest. So let's write down the value of mean. We just need to compare. We don't need that much accuracy. So we calculate the estimate mean. We calculate the estimate mean as 62.5. just for comparison, and we know the median to be 58.80189. we don't need that much actually, just the comparison would do. Now if you remember about skewness, it means whether the data is leaning towards some value. For example, if you have the idea is something else and most of the data is above that, and we call it positively skewed. If it is below that, we call it negatively skewed. Data is leaning towards something. So if you have the median here and the mean is greater than the median, then we call it positively skewed. If the mean is less than the median, we call it negatively skewed. Since here the median is less than the mean, meaning the mean is greater, we can say it is positively skewed. But there must be something wrong in the calculation, because in the previous sum we got a negative value and here we find a positive value, so there must be some mistake in the calculation. So let me calculate this again, where we calculate the negative skewness. Here the formula that they have given for skewness, so these two can be different, so maybe there was a mistake made here. So I want to calculate this again. So this is 67.12162 minus 2 into 58.80189 plus 52.48113. this is equals to this. Okay, last time there was a mistake in the calculation, so divided by bracket 67.1216262 minus 52.48113 bracket close. So it should be 0.1365. so there was a mistake here, so let me clear this. This should be .1365. Okay, so it should be let me get back 0.136537 0.136537 and it would be positively skewed. So we are lucky we just found this, because this two has to match. So positively skewed, positively skewed. So this is the calculation. The calculation is very long, it's tiresome. If you practice over and over again, it'll be alright.